Okay, so there's midpoint RAM, there's left RAM, there's right RAM, and here's our last approximation method for the area. It's using the trapezoids, or using trapezoids. So in class, I quickly drew y equals x squared, and it wants us to go from 1 to 4, and instead of breaking it up using rectangles, it wants us to break it up using trapezoids, and I'm sorry, it goes from 1 to 2, not 1 for 4. 4 subdivision means 4 trapezoids. And again, I think the trapezoids do the best job. We thought a midpoint RAM produced a great estimate. I think the trapezoid produces an even better estimate. Look how nicely those trapezoids go along with the curve. All right, so it's very similar to finding the area of the rectangles, but this time we're not doing length times width. We're looking at the area of each trapezoid. So I know the formula. Let me remind you of the formula for the area of a trapezoid. It's 1/2 times the height times the sum of the bases. So there's 4 trapezoids, and they're all going to have this 1/2. So I'm going to pull out the 1/2. And now, let's make sure we understand for each trapezoid the part. So we'll start with this trapezoid right here. And this trapezoid, f of 2 produces the length of one base, and this value right here, that value right here produces, so let me label this, this is 1.75, this is 1.25, that's 1.5, and this is 1.75. So here's the height, the base length of this trapezoid right here. The base length is f of 2, and then the other base is f of 1.75. This right here, the change in x, this right here, for the rectangle, it used to be the width of the rectangle, but for the trapezoid, this is the height. So the height for each trapezoid, again, base 1, base 2, that's the height, that's the height, that's the height, that's the height. The height of each trapezoid is going to be the same. If I'm going from 1 to 2, and I'm doing 4 subdivisions, so 1 to 2, 2 minus 1 divided by 4. Back in the first section in chapter 6, this represented the width of each rectangle. Today, it represents the height of each trapezoid. And again, since each one of them have the same height, so I took this as a GCF out and I took this as a GCF out. Now, all I'm going to do is add the bases up for the 4 trapezoids that you're seeing. All right, so one more time. This trapezoid right here, one of the bases is found by f of 2, and the other base is f of 1.75. Now I'm going on to the second trapezoid. Base is 1.75 plus f of 1.5. Then I have I'm going on to this one, f of 1.5 plus, that's f of 1.25. I'm running out of space. F of 1.25. Last trapezoid, it's this one right here. It's f of 1.25 plus f of 1. Check your work. You should have a total of 8 values. 2, 4, 6, 8. And you have 8 values because you have trapezoid 1, trapezoid 3, trapezoid 1, trapezoid 2, trapezoid 3, trapezoid 4. You can just grab a calculator and go work this out. And then let's look at number 2. How do I find the estimate the change in the temperature? And this is the rate. It's degrees Celsius per second. They gave you the rate. So if I need to estimate this integral, I'm going to call the derivative to be c prime of t dt. And that's the derivative that's given. I need to estimate the change in the temperature. I need to integrate that. And they want me to integrate or estimate by using 4 trapezoids. So yes, you can draw this out. Or we can sort of be efficient by just looking at the table. The seconds are going up in order, 0, 1, 2, 3, 4. So that's great. These are going to be the y values. The y values are going to be the bases of my trapezoid. And I am doing 4 trapezoids again. If the time is going up by the same interval, then that means the height of each trapezoid is going to be the same. And again, we're going from 0 to 4. They want us to do 4 trapezoids. So the 1 represents the height of the trapezoid, of each trapezoid. So I know it's silly, but I'm going to take out the 1 as a greatest common factor. I'm going to take out the 1/2 because it comes with the formula. There it is. And now, guys and girls, we're supposed to have a total of, just like before, hopefully it won't run out of space this time. Just like before, I'm supposed to have 2 bases here, 2 bases here, 2 bases here, 2 bases here. So let's see how you can do this without graphing it. I'm going to just sketch it really quickly just to show you a couple of them. 0, 3 is right here, 1, 4 is right here, and here's 2, 5. And it seems like they come back down and they go up because that's 3, 4. So this right here, guys and girls, this is 0, 3. This is 1, 4. This right here is my first trapezoid. We know the height is 1. This base right here is 3. The second base length is 4. That's my first trapezoid. Let's go on to my second trapezoid. Here's my second trapezoid. The base length right here of the second trapezoid is this 4 again, and 5 is its second base. Let's go on to my third trapezoid. It's going to steal this 5 as its one base. 4 is the other base length. Last trapezoid, 4 is the first base length, and 7 is the last base length. And again, just making sure we have 1, 2, 3, 4 trapezoids, a total of 8 bases. Go grab your calculator if you need to and go work out this calculation. Finish number 3, please, and then there's some textbook problems as well.